Hey guys, welcome again to the Maths Club. If you're just joining us, you're welcome. In this video, we're going to start something fresh, and we're starting with the first topic under plane geometry, titled Angles and Intercepts on Parallel Lines. We're going to look at how to find angles between parallel lines and when you have intercepts and things like that. So I want you to sit tight and let's get started. Angles. Angles at a point add up to 360 degrees. Right, so if you're at a point and you go around that point, you've gone 360 degrees basically. The degree is the most common unit for measuring angles. We said a full turn is 360 degrees. We established that. You remember when we were doing latitude and longitude, we talked about degrees and we talked about minutes in terms of the measurement. So one thing you need to know is that 1 degree is equal to 60 minutes. And just like we know, 1 minute is equal to 60 seconds. That's standard. So now the types of angles. The first we're looking at is the acute angle. An acute angle is an angle between 0 degree and 90 degrees. So you can see, if you have a quadrant like this, this is our 0 degree, these are 90 degree, these are 180 degree, these are 270 degree, these are 360 degrees. So I mean a full circle turn. We started from here, went to back here, is 360 degrees. We established that. So any angle between this place here, between 0 and 90, so between 0 and 90, right, it's not 0 and it's not 90, it's just between. It could be 77, could be 60, it could be 30, so anything between this range here is known as an acute angle. So you can see this angle theta is still within this first quadrant. If you draw your quadrants here, you'll see that it's still within that first quadrant. So that's an acute angle. Second is a right angle. So you know that quadrant, if I draw it here, we had a quadrant here, and we said this 0 degrees, this 90 degrees. So when an angle is exactly 90 degrees, you see something like a small square here, right? To symbolize that it is a 90-degree angle or a right angle. When it's exactly 90 degrees, call it a right angle. And you see a typical example here. This theta, once you see this square, you know that theta is at right angle. Third is an obtuse angle. So still continuing the line of our diagram, this 0 degrees, this 90 degrees, this 180. We said 0 to 90 is what? Great, acute, right? We're talking about 90 degrees. Then we're saying anything between 90 and 180. It does not include 90, it does not include 180. So anything here is known as an obtuse angle. Can you give me an example of an obtuse angle? Great, so correct. So something like 100, 130, 140, 150, 92, 91, those are all obtuse angles. So you can see an example here. Fourth is a straight angle. You know, when it is exactly on a straight line, it is exactly 180 degrees. And that's what we talk about straight angles. So you can see, if you do the quadrants, you see that this is exactly 180 degrees. So it has come here and it has gone all the way down here. I can use my right. Let me see. It started from here and moved all the way here, right? So you can see that it's created an exact straight line, and that is 180 degrees. That is 180 degrees. The fourth is a reflex angle. A reflex angle is more than 180 degrees but less than 360 degrees. So if I draw my quadrants again, this 0, this 90, this 180, this 270, and this 360. So anything greater than 180 but less than 360, so anything within this range here, is known as a reflex angle. So you can see an example here. This theta is greater than 180 but it's also less than 360 degrees. So angles between lines. First thing I said is that the sum of angles on a straight line is 180 degrees. So you can see these are, we have different lines here, but we know that on a straight line, it has to be straight. The sum of angles there, theta, would be 180 degrees. We established as before. So if I pick the first guy, which is f plus a plus b, so look at this like our line 1. We can see f, we can see a, we can see b on that line. So that gives us 180 degrees. The next one is ABC. So if these are line 2, angles A is on it, angles B and angles C. So by the time I add them up, they give 180 degrees. And if these are line 3, What angles are on line 3? Angles B, angles C, angles D, and that gave us 180 degrees. Line 4. If I say this is line 4, we still have our F and A and B, which we already have, so I'll skip that. And if I say this is my line 5, I would still have my A plus B plus C, which I already have here. It's just repeating myself because the same angles cut across them. On the other side of line 3, so this is one side of line 3, this is one side of line 3. On the other side of line 3, we have E plus F plus A, right? By the time you add these three together, they also give you 180 degrees. Sum of angles at the point is 360 degrees. We've established that. But by the time we're going to add all of this, so if these are points, let's say these are points O, so sum of angles at this point here, by the time I add A plus B plus C plus D plus E plus F should give me what? Beautiful. 360 degrees. The third point is vertically opposite angles are equal. First thing is that always look for an X sign. Look for an X sign. So you see this X sign, it's always be there. When you see an X sign like this place here, from here up to this point here is the angle A, and then from here up to this point here is the angle C. So you can see the A is opposite C because they are vertically opposite angles. A is equal to C. Once you see this X, just know that whatever is up here, so if I blow this up, whatever is up here would also be what is down here. They must be opposite each other and they're equal. Same thing too, you can see this X, whatever is here is also equal to whatever is here. So if this is A, this is B, this is C, this is D, while A is equal to, in this case, so while A is equal to B, in this case here, C will also be equal to what? D, for this example. In this case, while A is equal to C, B will also be equal to what? You see that this place is split into two. B is just equal to E plus D. So by the time I sum these two, it will be equal to the opposite. First thing to note is that always look for the X sign, and opposite angles are equal when you have the X sign, basically saying vertically opposite angles are equal. Let's move to parallel lines. Parallel lines are lines in a plane that never meet or intersect, no matter how far they are extended. So you can see something is parallel to another, they would never meet or intersect. They always remain the same distance apart. These are two things. They never meet nor intersect, no matter how far they are extended, and they always remain the same distance apart. These are two key things of parallel line. If it doesn't have these two features, feature 1 and feature 2, it is not a parallel line. If two horizontal lines are cut by a diagonal line, that diagonal line is the transversal. So let's see. Here we have two horizontal lines. These ones are not just horizontal lines, they're also parallel lines. So this is parallel line 1, parallel line 2. I'm not doing that two of them are parallel. You can see the number of arrows in one with the same number of arrows in the other. So if there were two arrows in this one, if they are parallel to each other, this one will also have two arrows. If this one has two arrows, this one has one arrow, they are not parallel to each other. But one arrow means that they are parallel. 3 arrows and 3 arrows mean that they are parallel. 2 arrows and 2 arrows means that they are parallel. No arrow and no arrow, you cannot say that they are parallel. You cannot say that. Because of trying to separate normal horizontal lines or parallel lines, we use these arrows. Now, these two horizontal lines, which are in this case parallel, they are cut by this diagonal line. This diagonal line is the transversal, so it's going from one line to another, going from one to another. So for parallel lines, there are some laws that apply. First law is corresponding angles are equal. What do you mean by corresponding angles? Corresponding angles are angles in the same position when a transversal crosses two lines. So let's see what I mean. First things first, the first step that these two lines are parallel. These line 1, line 2 parallel to each other. Then this line here is a transversal. You can see that it is cutting across line 1 and line 2. Because this line is parallel to this line and they're the same distance, you can see they're almost like identical. If this guy is making an angle Y here, right? If this transversal is making an angle Y with this horizontal parallel line, it's going to make the same exact angle with this other parallel line, because they're the same distance apart, and then it's the same transversal line that is cutting through both of them. So you can see this is to the left of the transversal, this also to the left of transversal for two parallel lines. In this case, x is a corresponding angle to y, right? Whatever I'm seeing here, I can find the corresponding thing in this line here. So in this case, x is equal to y. Same thing too, if this applies to this place here, the same thing applies to here. You can see a is also equal to b, because this is just below the line, this was below, and they are parallel to each other. So a would also equal to b. If I had something like this, and this is c, and this is d, what can you say about c and d? Great, they are equal to each other because it's the same transversal and they are corresponding angles. So these are things that you need to know. Alternate angles are equal. Alternate angles are angles on the opposite sides of the transversal between the two lines. What do I mean? You get that now. So they are often shown in a Z shape. So we say Z angles. Whenever I see something like this is a transversal line. These are parallel lines. Remember we said this guy would be equal to this guy, Abi? Would be equal to this guy, right? And remember when we said we have an x, if we have an x, vertically opposite angles are also what? Equal. So B will also be equal to C. But to save the stress of all those things, they just said there's a law called alternate angles. So you know we had corresponding angles. Corresponding angles is the same side, right? Alternate angles are the opposite sides, right? Alternate, opposites corresponding the same. So if this guy is inside, I mean these are parallel lines, this is transversal, this is the Z that they talked about. See the Z, this is the Z here, you can see the Z. So if this guy is outside, I mean depending on how you look at it, this could be inside the Z, this guy is inside the Z, this guy is outside the Z, and they are the same. B is equal to C. So whenever you see the Z, the left is always equal to the right. Left is always equal to the right, right? You can see they are still inside the same boundary of the parallel line. They're inside the same boundary of the parallel line. This guy is inside this boundary here, right? B and C, they are inside the same boundary. Don't go and say B and put something outside. No, they are within the same boundary. So B is equal to C. Same thing too, we still have the Z. If the right is equal to the left, then also the left is equal to the right. So how do I know it? I'll just say the right top is equal to the left bottom, and the left top is equal to the right bottom. So A is equal to D. Once it has Z shape, just know it. You can start doing corresponding angles and trying to find the X, but that will be too many laws that you have to, because for these questions you have to state why you are saying they're the same answer. Because with the theory question, you can't just say B is equal to C, you have to state why it is, right? So I mean this one will just streamline your answer to just one law: alternate angles are equal. Sum of interior opposite angles is 180 degrees. So look at this, we have A and C, right? Same thing, so you can use any of the laws that I've talked about. So if you look at this place here, if this is A and these are parallel lines, of course this guy too would also be A, because they are corresponding angles, and you know that this angle in a straight line, you can say A plus C is equal to 180 degrees, right? But to save you the number of laws that you have to cut, right, just know that the sum of the interior opposite angles, so these are opposite interior angles, these two guys, they are opposite to each other, right? And they are inside the boundary. So A plus C is equal to 180. Also, to these two guys are opposite each other, up and down, right? And they are within the same boundary of the parallel line. So B plus D is equal to 180 degrees. When we start solving questions, you will see some of all these things in practice. But you can see that the laws are really just an application of each other. They're just trying to streamline the number of steps you take. This one, exterior angle theorem, is not particularly concerned with this particular topic. It's meant to be the next topic we could talk about, but it's very essential for us to know this at this point. Whenever you have a triangle like this and you have an external angle E, E is always equal to the sum of the opposite interior angles. So E is equal to A plus B. The measure of an exterior angle of a triangle, the exterior angle is E, is equal to the sum of the opposite interior angles, the two opposite interior angles. That's E is equal to A plus B. That's given. So if I also had something like this, and this is F, what would F be? Beautiful. F would be equal to A plus C. So the ones that are opposite, this guy is opposite these two guys. So A plus C would give me F. E is opposite these two guys, so A plus B would give me E. So you can see that. Let's see some questions. Question 1 says that in the figure below, find the value of y from JAMB 1991. I want you to pause the video and try this out yourself. So we have this guy. One thing I want you to know is that whenever you have something like this, a parallel line, feel free to extend that parallel line if you need to. If you think you need to, just extend it, right? Just extend it. So we are trying to find, look at this transversal cuts across this place, but there's also a line here. This one is not part of the transversal, but these are two parallel lines. So in that two parallel lines, we can see the transversal. This is the transversal. We know the angle in the straight line is 180 degrees, right? So this guy here would be 180 minus 152, which will give you 28 degrees, right? Because angles on a straight line is equal to 180 degrees. Is that not it? So this guy is 28 degrees. So if I draw here, I'll say this guy is 28 degrees. Great. If I know this, I can find the angle here. I can find the angle here. I mean, there's no one way to solve these questions. That's one thing you need to know. But I'm trying to solve it in a way that will combine so many things, so many laws that we have done. From that exterior angle theorem, we know that the angle here will be equal to the sum of the opposite interior angles, the two opposite angles. This is the top and bottom opposite this guy. So this guy here would be 30 plus 28 degrees, which is equal to 58 degrees, right? Why? From the exterior angle theorem. That's the reason why. Now I know this guy. Can you see in this place here? See this transversal cell parallel line, because that's forming an X, right? So this guy is 58 degrees. This guy here is also 58 degrees, right? Why? Because since the vertical opposite angles are equal, so we could just say are equal. Now we have this guy. We can find y, because this 58, this is y. We know that opposite interior angles sum up to what? 180 degrees. So I could say 58 plus y is equal to 180. Y will be equal to 180 minus 58, and that'll give me 122 degrees. Why? Because opposite interior angles are equal. So found the value of y, and we've used a range of different laws that were given. You might solve in a different way, like I said. I just had to do this because I had to show you all of the laws. And again, feel free to always extend a parallel line if you need to. Let's see if answer is correct. That will be option B. Great. Question 2 now says that three straight lines EF, so this EF, GH, and LK intersect at O, as shown above or below in this case. If angle KOF is 52, LOH is 85 degrees, find the value of EOG. Pause the video and try this out yourself. So when I see this question, first thing I see is this X. I see this X. And if this guy is 85 degrees, this guy is also 85 degrees. Why? Because of vertical opposite angles are equal, right? Is that not why? That's why. So GOK is equal to 85 degrees. Now we know that angle on the straight line is 180 degrees, and we're trying to find EOG. This is our X, right? So angle EOG plus angle GOK plus angle KOF is equal to 180 degrees, right? Because angle on a straight line. So we know this guy to be 85. We know this guy to be 52 degrees is equal to 180 degrees. So this is angle EOG. So 85 plus 52, that's 7, 137 is equal to 180 degrees. So angle EOG plus 137 is equal to 180 degrees. So angle EOG will just be 180 minus 137, and I'll give you 43 degrees. Let's see if we're correct. That will be option B. Great. Question 3 says that we should find the unknown angles below. So we have this. I encourage you to pause the video and try this out yourself. So when I see this, the first thing I see is an X. I see an X here. So T is equal to 30 plus 70 degrees, right? Because of what? Let me first, this 100 degrees, because of vertically opposite angles are equal, right? Is that not it? Great. If this is T and this is S, our S here would be equal to 180 minus 100 degrees, and that'll give me 80 degrees. Why? Can anybody tell me why? Great, because opposite interior angles sum up to 180 degrees. So these are opposite interior angles. This is my parallel line, this is my parallel line, and the inside, this is my transversal. So you can see that. So this is my parallel line, this is my parallel line, this is the transversal line, right? So this guy is above my parallel line, this guy is above my parallel line. So of course my U is 30 plus 70 degrees, which is 100 degrees. Why? Because of what's corresponding angles. So corresponding angles are equal. Is that not why? Great. Now that I know that this guy here, my W is 80 degrees. Can anybody tell me why it's 80 degrees? Great. Because it is a vertically opposite angle with S, and S is 80 degrees. So because of vertically opposite angles are equal. So that's basically it. Once you know the rules, they become child's play. So we know our T, let me start with our S. Our S is 80 degrees, our T is 100 degrees, our U is 100 degrees, our W is 80 degrees. Let's see if we're correct. Great. Question 4 says that in the diagram below, BA, this BA is parallel to DE. Find the value of X. This will work 1993. I want you to pause the video and try this out yourself. So we're trying to find this X, right? In this X, there's no parallel line around it, but we can draw one parallel line. It is allowed. So if I do something like this, let me drag it down here. Good. So I'm going to put the arrow to show that it's parallel to these two other lines. This is permitted. So these are line 1, these are line 2, and this guy here is a transversal line. This guy here too is a transversal line between these 2 points. We have 2 transversal lines and we have 3 parallel lines. If this guy is 52, what do you think this guy is? Great, it's also 52 degrees. And can anybody tell me why? Great, because of alternate angles. No said, we said you should look for a Z. So these are Z here. These are Z here. You can see it. So the top right is equal to the bottom left. So this 52 degrees. Now, if this guy is 312, what do you think this guy will be? Great. This will be 360 degrees minus 312, and that'll give me 48 degrees. Why? Angles at A points, right? This one is alternate angles are equal, right? You should know what all of all this shortcuts means. Don't write this kind of thing in your exam. Write the full meaning if it's a theory question, and be able to properly identify your points, right? I mean, make it more intelligent for the teacher. Now, with all this place here, we also have another Z here. You can see it's this under Z. In case you didn't see it, is under Z. So with that other Z, what do we know? We know that the bottom right would be equal to the top left. Bottom right, top left. So this 48 degrees, this guy is also 48 degrees. Why? Because alternate angles are equal, right? So we have these 2 points. I know that this point plus this point plus this point will give me 360 degrees, because angle at the point is what? 360 degrees. So I know that X plus 52 plus 48 would give me 360 degrees, because angle at a point is 360 degrees, right? So X plus this will give you 100 is equal to 360 degrees, and our x is equal to 360 minus 100, which will give you 260 degrees. So our x value is 260 degrees. Let's see if we're correct. Great. Question 5 says that in the diagram below, AO is perpendicular to OB. Find x. So AO is perpendicular to OB. So this is basically a 90 degrees. When you say perpendicular, you know that is 90 degrees. So find x. So if this place is 90 degrees, we know that 4x plus 3x plus 2x plus 90 degrees will give me what? 360 degrees, because angle at a point is 360 degrees. So this is 479. 9x plus 90 is equal to 360. 9x is equal to 360 minus 90. 9x is equal to 270. And if I divide both sides by 9, my x is equal to 30 degrees. That's basically it, because questions also find x, and we are done. That will be option D. Question 6 now says that in the diagram, angle PQU, let's see this. So this is PQU. Okay, PQU is 36 degrees. Angle QRT is 29 degrees. PQ is parallel to RS, and you can see these two arrows, these two arrows. Great. And UQ is parallel to RT, one arrow. Great. Find the value of PQR. So this P is Q, this R. So we need to find the total. We know one part is really 36 degrees. Pause the video and try this out yourself. So given this, we have been given one part. So 36 plus something will give us angle PQR. But this line is parallel to this line, and this is a transversal. You can see a straight line cutting across this two, and you can see this is a typical example of a Z. Can you see the Z here? So if the bottom right is 29 degrees, the top left would be what? 29 degrees. Why? Because alternate angles are equal. And with that, we found the missing part of the PQR. So therefore, angle PQR is just 36 plus 29, and I'll give you 65 degrees. Let's see if we're correct. That will be option B. Great. Question 7 now says that in the diagram below, PQ is parallel to ST. Find the value of x. This is from WAEC 2002. I want you to pause the video and try this out yourself. So we have this. This is a parallel line. This is a parallel line. This one was meant to be the transversal, so I can extend it. Right, it's a straight line, so I can extend the transversal line. Great. So if this guy is 110 and is to the right of the parallel line, and this is the same parallel line, this is the same transversal, this guy here would be 110 degrees. Why? Corresponding angles are equal. If you are getting anything wrong at this point here, please go back again and watch the video from the beginning till you get it. And if you have watched this point and you enjoyed it, drop a like on the video. And if you're not subscribed to our channel, please do. If you have any question, drop it in the comment section. I'll reply to it as soon as possible. Great. So this guy is 110 degrees. I can find this guy. Why do I need to find this guy? If I'm finding x, I know that the external angle is equal to the sum of the opposite interior angles. So I know that 54 plus whatever this guy is would give me x. Remember, from the exterior angle theorem. So I know that from here I can find this guy here. So angle RTS is going to be 180 minus 110. Why? Because it's an angle on a straight line. This guy plus this guy will give me 180, so this will give me 70 degrees. This will give me 70 degrees, and I can easily find my x. And say x is equal to 54 plus 70. Why? Exterior angle theorem states that the external angle is equal to some of the opposite interior angles, the two opposite interior angles. So that will give me 124 degrees. So my angle x is equal to 124 degrees. If I can extend the parallel line as the previous questions, I can also extend a transversal. Right? This guy was already going straight. And that is the key to solving this question. Let's see if we're correct. That would be option C. Great. With this, we've come to the end of all of the examples that we're treating on this particular topic. In the next video, we're looking at the WAEC past questions that contain some of all these things. See you there. Bye for now.